Welcome back to our channel, hoping that you are doing well wherever you are. We are going to still talk about strip foundation, but today we are going to talk about the reinforcement detail for the strip foundation. So we shall start by uh, describing what is a strip foundation. So a strip foundation, it is a continuous strip of concrete that serves to spread the weight of a load-bearing wall that is across an area of soil. It is a component of a shallow foundation. So it is a component of a shallow foundation, and I've said that it is a continuous strip of concrete that serves to spread the weight of a load-bearing wall across an area of soil. So strip foundation is normally detailed in this manner. And before we talk about the detailing, the reinforcement detailing of the strip foundation normally fails due to shear force or shear failure. So the shear failure on a strip foundation, it normally acts at an angle of 45 degrees. So it normally acts at an angle of 45 degrees. So as you can see in our illustration here, so this line here is a line of shear. This line here, it is a line of shear. So this is a line of shear. So our angle that will be formed, that is by the shear failure here, it will be at an angle of 45 degrees. So this angle shall be 45 degrees. And if the angle of shear failure is 45 degrees, remember that this angle is 45. So this angle here will also be 45. So if this angle is 45, our angle here at the top is 90. So here our angle shall also be 45, so that it makes 180 degrees. So if then that is the case, as you can remember, a right angle triangle, that is a right angle triangle whereby the two angles are 45 and one angle is 90, that is to make a summation of 180. Therefore our P, whereby P is the projection of the footing, has to be equal to the depth of the footing. So like for example in our illustration here, if our P, that is the projection of the footing, is 200 millimeters, then the depth of our footing shall be also 200 millimeters. So therefore our detailing, reinforcement detailing for this strip footing shall be this way. It is normally done this way. We normally have, like the way our illustration is showing, we normally have the main bars and we have the distribution bars. If we can see in our plan is indicated like this. We have the distribution bars and we have the main bars. It is the same way as we do the detailing reinforcement for the slab, whereby you will find that the main bars, they do run along the shorter span, whereas the distribution bars, they do run along the longer span. So this longer span of our strip footing is the longitudinal span, which is also the perimeter of the strip footing. So the perimeter, the bars that run along the perimeter of the footing, these are the distribution bars, and the bars that run along the shorter span, those will be the main bars. And normally the main bars are the bottom one bars and the distribution bars are the bottom two bars. So again, if you look in our cross section here, so in our cross section we have the line of shear at an angle of 45. That's the line of shear. So our bars in our cross section will look like this, whereby our bottom one bars, that is running along the shorter span. So our bottom one bars, this shall be our main bars, and then our distribution bars, these shall be the bars that run on the longer span, that is the perimeter of the strip footing. So our bottom one bars, or rather our main bars, shall be the bars that will be running, that is along the shorter span, and our distribution bars shall be the bars that will be running along the longer span. So remember, our main bars shall be the bottom one bars. So these bottom one bars are normally the bars that are cut and bent in a U-shaped manner. So it's like a U-shape. It's like a U-shape. So in our cross section here, so for the foundations, so as you can see, this line here, it is indicating the bottom one bar, and this line here, it is indicating the edge of our footing. So we have the space in between, the bar and the concrete. So this space is the cover. So this is the cover to reinforcement that is on this strip footing, and minimum cover is normally 50 millimeters, that is to foundations. So we can remind ourselves again, this is the line of shear. This is where the failure takes place when strip footing, or rather when strip foundation fails. So it is the line of shear, and it normally takes at an angle of 45. So for us to counter this failure at this angle of 45, we normally do the reinforcement detailing, whereby we will have our main bars as bottom one bars, and then we will have our distribution bars as bottom two bars. So to counter this shear failure that is on this strip footing. And again, we remind ourselves by saying that the projection P, this is the projection P, is normally equal to the depth of our strip footing, because the shear will act at an angle of 45, hence making a right angle triangle. So our projection P will be equals to depth D. For example, if we have our projection P as 200, if we have our projection P as 200, then we will have our depth D as also 200. For example, if we have our walling of 200 millimeter, our walling is 200 millimeter. That is the foundation walling is 200 millimeter, and then the overall width of our strip footing is 600 millimeter. So 600, if you subtract the 200 for the walling, then we will have a remainder of 400 millimeter. So this 400 millimeter will be divided into two. So this side will have 200 and this side will have 200. So our projection P, which is equal to 200, shall be equal to our depth D, which is also 200, since shear failure occurs at an angle of 45 degrees. So that is how we detail our strip footing in terms of reinforcement, and that is how the shear failure occurs on the strip footing. Thank you, and please continue subscribing for more construction basic knowledge.